Hello students, this is Professor Chalai, and in this video we're going to start chapter 4, Stoichiometry of Chemical Reactions, by looking at how to balance chemical equations. By the end of this video, you should be able to write chemical equations from simple word problems, and also be able to balance those chemical equations. Let's get started. Before we can balance chemical equation, you might be asking yourself, well, what is a chemical equation? Well, a chemical equation is simply a symbolic representation of a chemical reaction. As I've mentioned many times over the course of this semester, oftentimes before we can study things, we need to be able to represent them and write them down in ways that we can easily understand. And so a chemical equation is simply a representation written down on a piece of paper of a chemical reaction. There are going to be two sides to any chemical equation. On the one hand, we have reactants, which are simply the substances undergoing the chemical reaction. And in a chemical equation, they're placed on the left-hand side. On the other hand, a product are the substances formed during a chemical reaction and in a chemical equation they're placed on the right hand side. So for example, let's say you have some reaction where you have a reactant 1 and a reactant 2 reacting together to produce a product. Let's say you form three products. It'll be product 1 plus product 2 plus product 3, and your equation might look something like this. And we'll get into more concrete examples right now. So in this equation, you'll notice the reactants are on the left-hand side. We add a plus sign to just show that they're reacting together. There is an arrow showing the direction of the reaction. They're going from reactants to products. And then on the right-hand side, we have all of our products, in this case, 3 different products, separated by plus signs to show that these are all the different products formed. So this is what a chemical equation sort of looks like with all of our reactants and products. And typically in any reaction, because we learned that matter cannot be created nor destroyed, whatever you started with, all of the atoms that you've started with are going to be the same as all of the atoms that you end up with, just in different combinations. So from that point of view, your reactants on the left-hand side and the reactants on the right-hand side must be balanced. And by balance, we mean the numbers of atoms that you start with should be the number of atoms that you end with, or the number of moles of atoms that you start with should be the number of moles of atoms that you end with. And similarly for charges, if you start with a number of charges for your reactants, you should end up with the same number of total charges on the right-hand side. And finally, the other thing that we need to include in chemical equations are what we call state labels or state symbols. And typically, these are all the only ones that we'll be interested in this course are going to be S for solid, L for liquid, G for gas, or AQ for solutions where the solvent is water, so it's an aqueous solution. They're just the lowercase letters inside of parentheses immediately following the chemical symbol. All right, so these are all the things we need to consider when we're writing and balancing chemical equations. But let's look at a more concrete example. Let's look at number 1, where it says, write the balanced chemical equation for C4H10 gas combustion. So this is a word problem, and they're asking us to write the balanced chemical equation from it. The first thing we need to remember is, what is a combustion? So earlier we talked about how combustion is reacting with oxygen, excess oxygen, to form various products. Specifically, the carbon goes to form carbon dioxide, and the hydrogen goes to form water vapor. So let's write a balanced chemical equation for this. First, we'll start with a chemical equation that's not balanced. So here we'll have C4H10 gas. This is a combustion reaction, so that means it's reacting with oxygen. So these are going to be our reactants, oxygen gas. Then it goes to form our products. The carbon goes to form carbon dioxide gas, and the water goes to form water vapor, or H2O gas. Now that we have sort of an unbalanced chemical equation, we need to balance this. There are going to be two ways that I would show you how to balance chemical equations. The first is sort of a guess and check method that can sometimes be very quick. Can be very quick, but it will require a bit of intuition. So this is sort of what the guess and check method looks like. In the guess and check method, we pick an atom on the left-hand side, and let's start with the first atom here, carbon, because it only appears once. We'll start with that. There are 4 carbons on the left-hand side, and we look at the right-hand side, and there are only 1 carbon on the right-hand side. So to balance that, let's just multiply that whole thing by 4. So now there are 4 carbons on the left and right-hand sides of this equation. Okay, now let's pick a different element and make the same sort of guess. So on the left-hand side, we have 10 hydrogens right here. On the right-hand side, we only have 2 hydrogens. So if we want to balance the right-hand side with the left, we need to multiply this whole thing by 5. So 5 times 2 gives us 10, which will balance with that 10 hydrogen over there. Okay. Now, the only thing that we need to balance, the only thing remaining that we need to balance is oxygen. There are 2 over here, but on the right-hand side, there's 4 times 2, there's 8, plus 5, which gives us 13. So there's 2 oxygens on the left-hand side, there are 13 on the right. There's no number we can multiply on the left-hand side here to equal 13, because 13 is an odd number. So you might be thinking, oh, there's an issue here. But not really. Let's multiply this whole thing by 13. This gives us 26. And so all we need to do is multiply everything on the right-hand side by 2 to give us 26 oxygen atoms as well. So that means instead of 4, we'll have 8 carbon dioxide, and instead of 5, we'll have 10 water. Everything should now be balanced, but it's always a good idea to go over your balance equation and check everything with a fine-tooth comb, if you will. So let's check everything. Let's check our carbon. On the left-hand side, oh, I forgot. If we multiply these guys by 2, we also have to multiply this by 2 to make sure that the carbon and hydrogen that were balanced in the beginning are still balanced in the end. Okay, now let's check all of our elements. Let's start with carbon. On the left-hand side, we have 2 times 4, we have 8. And on the right-hand side, we have 8 here and nothing else here, so our carbon's balanced. Let's check our hydrogens. Here we have 2 times 10, which is 20 on the left-hand side, and on the right-hand side, we have 10 times 2 from the water, which is also 20. So that's balanced. Now let's check our oxygen. We have 13 times 2, which is 26 on the left-hand side. On the right-hand side, we have 8 times 2 from the carbon dioxide, which gives us 16, plus from the water, we have 10 times 1, which is just 10, or 26, so that's balanced. So everything's balanced, so this means that this equation here is our balanced chemical equation. That was sort of guess and check method, where you just choose an element one at a time and sort of play with the numbers on the left or right hand side until they match. Let's look at number 2. and we're going to use a slightly different method for that. Number 2 says, write the balanced chemical equation for solid silicon dioxide and solid carbon to produce solid silicon carbide and carbon monoxide gas. So here's a word problem where we need to first find our unbalanced chemical equation. So we have solid silicon dioxide. Silicon dioxide, based off of how we know the naming conventions work, means that we just have a formula of SiO2, silicon dioxide, and it's solid, so we put the state symbol S. The next compound that we have in this is solid carbon. It's just solid carbon. To produce, so we have an arrow, solid silicon carbide, and they give us the formula for that, so we don't have to worry about figuring it out. Silicon carbide, solid, and carbon monoxide gas. Carbon monoxide is 1C, 1O, and it's gas. Make sure you always write your state symbols, otherwise your equation will not be complete. Okay, so we have an unbalanced chemical equation, and I mentioned that we're going to look at how to balance this using a different method, not the guess and check method. In this method, we're going to assign temporary symbols for the numbers that are going to be in front of each of these different compounds. So on the left-hand side, we'll call this A number of silicon dioxide, B number of carbon. On the right-hand side, we'll call this X number of silicon carbide and Y number of carbon monoxide. Those are just symbols for the numbers that are going to be there later. Okay, let's just pick one element at a time and work with that. So let's pick silicon. On the left-hand side, there's A number of silicon, so A, and nothing else. And that will be equal to whatever's on the right-hand side. And on the right-hand side, there's X number of silicon and nothing else. So we just write X. So that means that A is equal to X, which means that we can either change A into X or X into A. I like to change, let's just change X into A because the two things are same. So now we change one of the little labels that we've made. Okay, let's pick a different one. Let's pick oxygen now. On the left-hand side, there's A times 2 oxygen, or 2A. On the right-hand side, there's Y oxygen, so we just put Y. So that means that Y is equal to 2A, so we just take the Y here and replace it with 2A. Okay, so let's look at carbon now. On the left-hand side, there's B number of carbons, and on the right-hand side, there's A number of carbons from the silicon carbide, plus 2A number of carbons from the carbon monoxide. So B then should be equal to A plus 2A, or 3A, so we take B and we change it into 3A. Now what you'll recognize is that all of the different compounds are written in terms of A. We have A, 3A, A, and 2A for each of them. So all we need to do now is set A equals to 1, and we have a balanced chemical equation. So let's write that balanced chemical equation. We have 1 silicon dioxide, we don't need to write the 1, plus we have 3A, or if we're setting A to 1, that just means we have 3 carbon, solid, going to give us A number of silicon carbide. A is just 1, so just silicon carbide, solid, plus 2A carbon monoxide gas, or just 2 carbon monoxide gas. This method is a little bit more involved. That certainly requires a lot more algebra, but it's not a guess and check method. So these two methods are both valid. You can use either one to balance your chemical equation. The guess and check method can be really fast. However, sometimes you might find that you can get stuck, in which case the second method might come in useful. Okay, you can pause the video right now and try numbers 3 and 4 by yourself and unpause, and we'll work it out together. Okay, let's take a look at number 3. Number 3 asks us to write the balanced chemical equation for a reaction between aqueous strontium chloride and aqueous lithium phosphate to form solid strontium phosphate and aqueous lithium chloride. Now, before we could write a chemical equation for this, we need to translate the names of these compounds into actual formula for the compounds. And this is where memorizing the different ionic compounds and how to name compounds come in useful. So let's look at strontium chloride. It's an ionic compound. Strontium is metal, chlorine is a nonmetal. Strontium, if you look at your periodic table, you would see that it has a charge of +2, whereas chloride we know has a charge of +1. So strontium chloride formula to balance the charge will be 1 Sr and 2 Cls to balance that out, and this is aqueous. Let's look at lithium phosphate. We know that lithium has a charge of +1. Phosphate, if you've memorized this, the formula is PO4 3-, so it has a total charge of 3-. So to balance this out, the formula would be 3 lithiums, so Li3, and 1 phosphate, so just PO4. And it says that this is aqueous. Let's look at strontium phosphate. Again, strontium has a charge of 2+, phosphate has a charge of 3-. So to balance that, we need 3 strontiums and 2 phosphates. So let's write that. So we have 3 strontiums and PO4, 2 phosphates. And it tells us that this is a solid. And finally, lithium chloride. Lithium has a charge of +1, chloride has a charge of -1, so we just need 1 of each to balance the charges. So the formula would just be LiCl, and they say that it's aqueous. So this is the unbalanced chemical equation. Let's try to balance this. Let's use the guess and check method for this one. So on the left-hand side, we have 1 strontium. On the right-hand side, we have 3 strontiums. So let's just make that a 3 so that we have 3 strontiums on the left-hand side. Okay, we have 3 times 2 chloride atoms on the left-hand side. We only have 1 chloride atom on the right-hand side. So let's make this a 6 so that it's balanced on the left and right-hand sides. Let's look at lithium. Lithium has 3 on the left-hand side, but 6 on the right-hand side. So if we multiply this whole thing by 2, we make that 6, and that's balanced. And now for phosphate, there's 2 phosphates on the left-hand side, 2 phosphates on the right-hand side. That seems to be balanced. Now, the special thing with balancing ionic equations, equations that involve ions, is we don't need to look at each atom separately. We can group the whole phosphate PO4 together. So we don't need to look at the phosphorus separately from the oxygen because they keep sticking together. So now this should be balanced, but just to double check, it's always good to double check. Let's do it. For strontium, we have 3 on the left-hand side and 3 on the right-hand side, so that's balanced. Chlorine, we have 3 times 2 is 6 on the left and 6 on the right, so that's balanced. Lithium, we have 2 times 3, which is 6, and we have 6 on the right-hand side, so that's balanced. And for phosphate, PO4, 3-, let's look at each atom separately. So phosphorus, we have 2 on the left-hand side, 2 on the right-hand side, so that's balanced. And then oxygen, we have 2 times 4, that's 8 on the left-hand side, and 2 times 4, that's 8 on the right-hand side, so that's balanced. So that's the guess and check method. It worked very quickly for this one. Let's look at number 4. Number 4, we'll use the longer method. And here, they already give us a starting equation, but they haven't balanced it. So let's use the longer method where we'll put a number of solid sulfur plus b number of aqueous nitric acid, so HNO3, aqueous, going to give us x number of H2SO4, sulfuric acid, aqueous. Remember, always write your state symbols, plus y number of NO2 gas, nitrogen dioxide gas, plus, let's call this Z number of water, liquid, H2O, liquid. Okay, so let's look at sulfur to start with. So sulfur, on the left-hand side, we have a number, and on the right-hand side, we have x number. So a and x should be equal, so let's set this to a. Let's pick a different element. Let's look at hydrogen. On the left-hand side, we have b, and on the right-hand side, we have 2 times a, so 2a, and 2 times z, or z. We can't simplify anything here because there are 3 unknowns, so let's keep that as is. Let's look at oxygen now, or sorry, nitrogen. So for nitrogen, there are B number of nitrogens on the left-hand side, and on the right-hand side, there are Y number of nitrogens. So right away, we know that Y and B are the same numbers. Let's look at oxygen. On the left-hand side, we have 3 times B, so 3B. And on the right-hand side, we have A times 4, so that's 4A plus 2 times B plus Z, or Z. We can simplify this equation further by subtracting 2B on both sides, and that will give us B is equal to 4A plus Z. And now we have 2 equations that are in terms of B. Like I said, this can be complicated, but we're going to get there. So the 2 equations in terms of B, we'll set them equal to each other. So for this one, we have 2A plus 2Z. And for the one below, we have 4A plus Z. Let's subtract 2A from both sides. We get 2A. 2Z is equal to 2A plus Z. We subtract Z on both sides. We have Z is equal to 2A. So let's make that substitution. Z is equal to 2A. All right, now that we have a formula for Z, let's look at this one again and substitute the value for Z. So B is equal to 2A plus 2Z, but Z is 2A. So 2 times 2A, that gives us 4A, or rather B is equal to 6A. So let's make that substitution. B is 6A, B is 6A. Now that we have all of them in terms of A, we can go ahead and set A equals 1 and balance the equation, where we would have 1 sulfur, 6 nitric acid, 1 H2SO4, 6 nitrogen dioxide, and 2 water molecules. Again, when you write the balanced equation, you can ignore the ones because they're implied. And that's it. That's our balanced chemical equation. Now, you might want to go ahead and verify that is in fact balanced by let's look at sulfur. There's 1 on the left-hand side, 1 on the right-hand side, so that's good. Hydrogen, there's 6 on the left, 2 plus 2 times 2 is 4, that's 6, that's correct. Let's look at nitrogen. There's 6 on the left, 6 on the right, so that's correct. Oxygen, there's 6 times 3, 18 on the left. 4 plus 6, 2 is 12. So 12 and 4 is 16, plus 2, 18. That's all correct. So it's balanced. If you tried this using the guess and check method, let me know how that worked. This is the longer method. They both should get you to the same answer. And I just wanted to show you both methods. In the next video lecture, we're going to talk about balancing ionic equations. I'll see you then. Bye.